Let's solve this linear differential equation, and we see that we have the dy dx here, and we have y to the first power here, right? And there's no other y's, there's no other dy dx. So you know this is linear. That's good. This is going to be a really fun one, because I don't need to find the integrating factor. Because here's the idea, okay? The strategy of solving a linear differential equation is that to force one side to be the derivative of a product of two functions. We have the dy dx here, we have the y here. And you see, we have sine x and cosine x. In fact, the left-hand side, it is already the derivative of two functions, and those two functions are just sine of x times y. You can double check. Well, when you differentiate sine of x times y, we use the product rule, right? So we keep the first function and we multiply by the derivative second. That's how we get the dy dx. And we add it with the second function, which is just y, and we multiply by the derivative of the first, which we get the cosine of x. It's positive. So we don't need to find the integrating factor. If you go through the process that I have shown you in the past, you end up with the same conclusion right here. So this is the punchline right here. Anyways, we proceed because this is already done for us pretty much, right? This is equal to x times sine of x. And then I can just go ahead, integrate both sides, right? So that this and that will cancel. On the left-hand side, we will have sine of x times y. And don't worry about the plus c. And this is equal to, and to integrate x times sine x, we have to use integration by parts. And of course, let's use the di method. And let's do it right here on the side. Let's put on d and I, and plus minus plus. 3 rows are enough. And I am going to be integrating sine x, because we can totally integrate sine x, right? And we are going to differentiate x. And when I differentiate x, I will get 1. And do it again, I get 0. And I can stop, right? 0 in the d column. And let's integrate sine x carefully. The integral of sine x, we will first get negative cosine x. And when we integrate negative cosine x, the integral of cosine x is positive sine x. And since this was positive sine x, we have to maintain the negative symbol right here. That's enough. And the product of the diagonals are the answers. So once we integrate this, we will have this times that. We will have positive x times negative cosine x. We will have negative x times cosine of x. And next, don't forget to attach the sign right here on the side. Negative 1 times negative sine x is positive sine of x. So this is it for the integration right here. And of course, we have to add a plus c on the right hand side. Okay. Well, next, we can just divide everything by sine of x. Let's go ahead and do that so that we can get the y by itself. And we'll also divide this by sine of x, and let's do it right here as well. Divide this by sine of x, and we also divide the c by sine of x. Okay, and we will have y by itself, and this is equal to, we will have negative x. Cosine over sine is cotangent, okay, and we have cotangent x. And we have sine of x over sine of x, that's just going to be plus 1. And lastly, we put down plus c times 1 over sine x is cosecant x. And this is it for the general solution. However, we do have this initial condition, right? This means when x is equal to pi over 2, we will have y equals to 2. So we plug in 2 into y, and this is equal to negative x is pi over 2. So let's also put that down right here. And we multiply by cotangent of x, which is pi over 2. And we add it with 1. And here we have plus c times cosecant, and x is pi over 2, like this. Okay, now let me ask you guys this. What's cotangent of pi over 2? You can look at here. We have cosine over sine, right? And it's pretty much cosine of pi over 2, which is 0 over 1, right? So this right here is just 0, and multiplied by negative pi over 2. Of course, everything right here will be 0. We have 1, like right here. And cosecant of pi over 2, you can look at 1 over sine x. When x is pi over 2, sine of pi over 2 is 1. 1 over that is still 1, so this is just 1. So all in all here we have 2 equals to 0 plus 1 plus c. So in other words, c will be 1, right? Subtract 1 on both sides. At the end, let's put this down. Y is equal to negative x times cotangent of x plus 1. And c is also 1, so you can just put on plus. Let me emphasize that for you. 1 times cosecant of x, like that. Of course, if you don't want to write down this one, you don't need to, but this is it.